Hey, hi everyone. How are you doing today? So today I'm going to cover different data type. So what is the data type? The data type is time series, one of the most complex, mostly used in data science. Not only data science, for is used for forecasting. It's used in economics. It's used in finance. Where it used in IoT, where we get a lot of sensor data. But now these are all time series. Now what I'm going to cover today is a basic analysis, decomposition, Hodrick's and Prescott filter, little bit of feature engineering, and also LSTM based multivariate regression. So a couple of libraries I'm going to talk about over here: Keras, StatMod, Pandas, Seaborn, as well as scikit-learn. Okay, so the basic libraries over here. You need to understand one thing. There's a difference between multiple and multivariate. Multiple regression focused, when I say multiple regression, it is you're talking about using multiple independent variables and trying to predict one dependent variable. However, in multivariate, either multiple independent variable or one independent variable is used to predict multiple dependent variable. To give you an example, let's say I'm trying to predict both the correlation, or not the correlation. I'm trying to predict both. The sensitivity and also the specificity using some kind of some kind of independent variables. So that's when it becomes a multivariate. So usually people, they do the mistake. Now, how is time series different from a basic regression or classification? Is usually we, in time series, the independent variable is time. So we are trying to see the effect of time on a dependent variable. It can be anything: gas, it can be electricity, it can be anything. So over here, what we will do, we will use gas and power are the two variables or dependent variables that we will combined it together, and we will see what is the effect of time as well as other aspects on gas and power. So that's how it becomes multivariate using LSTM, or long short-term memory, because it's a sequential data. However, we need to understand a couple of things before we proceed. What is white noise? So usually I try to test using white noise if my data has white noise. So how do I go ahead and test if my data has white noise, or what is white noise usually? So white noise is when your data, or your the data has a mean zero. Not the entire data set, the data that you're trying to predict has a mean zero. Standard deviation is constant with time. Okay, so what I mean by standard deviation in is this ups and downs. It's constant. Okay. Yeah, I have already run the code because I only get 15 minutes to cover a lot of things. And so just to step back, standard deviation is constant, mean zero, and there is a correlation between lags. And the correlation, or between there, rather, there is no correlation between lags where the correlation is zero. If these three assumptions, any of these three assumptions are violated, we are good to proceed with time series data, because that means our data does not have white noise. If we have white noise, stop doing time series prediction, my friends. Okay, so the second thing people usually get confused is between stationarity and this white noise. So there is small difference. The mean is constant, not zero. Okay, so that's the that's the thing about stationarity. So mean constant, standard deviation constant, and there is no seasonality. Okay, how do we find all these things? I'll show you, but let me answer one question that I usually get. Should we make our time series stationary? The general answer is yes. Okay, if you have clear trend and stationarity in your time series, then you can go ahead and model these components. Okay, so going ahead, what I'm going to do is I'm going to show you two types of decomposition. So my question was how to find this trend, cycles, or noise in the data set. We use something called a time series decomposition. Lot of things you have. There are a lot of things in decomposition, but I'm going to cover very basic ones. Over here, there are two things that you can use. One is a STL, which is called let me first show you STL. So STL is seasonal and trend decomposition using Loess. Okay. Now where do I find this? Is here. Okay. So I am using this. I think there is a good example. Oh yeah, there is a very good example. I have used it on my data set as well. This is one type. It will give you trends, seasonality, and residuals. Now there is another type which is called Hodrick-Prescott filter. Now this Hodrick-Prescott filter is mostly used when in economics, finance, because there are a couple of effects. What kind of effects are we talking about here? There are effects like short-term fluctuations. Over here, I think somewhere I saw it. Yeah, somewhere here. Okay, yeah, short-term fluctuations. There are effects where long-term movements or trends, business cycles. So these things are taken care by this filter, and it brings an equilibrium between smoothness of trend and the closeness to the original data. Okay, so let me show you how I have done the Hodrick's one. So here you see getting a cycle trend of the gas power. So gas power is what we are trying to decompose. Okay, now couple of things, other things that you need to know as well. What is autocorrelation? What is a partial correlation? How to plot them? What kind of plots are used? So let's go ahead and see. I'll show you prediction later. Let me go ahead and see. Yeah, so here is autocorrelation. Now, what is this autocorrelation? So to make you understand autocorrelation, let me show you this graph where the gas power, I see a trend. Not a trend. So I see that the gas power has many months, or it's observation. The data is observed throughout a time. So the time is in 2007 from March till December. I want to see what is the consumption, gas and power. Okay, so here I see that if I take March and I'm trying to, let's say, forecast December, okay, directly, then we have, or we still get this April, May, June, July, August, September, October, November. So these are the indirect effects. So see, March is not directly affecting December over here. We have many months in between, which is indirectly affecting December. Okay, so that's what we say, that our data is correlated. Okay, now if we have to remove this indirect effects, what we can do is find something called a partial autocorrelation. Okay, so partial autocorrelation is this graph. You can use a similar kind of graph. So over here you see these are the lag effects. I've taken 50 lags, and also I see that I will create a separate video on this, how to interpret this partial autocorrelation in this kind of a graph. There's a specific name to this graph as well. So let me just go ahead and tell you that if you see the points or black points over here which are inside this area, then it's not statistically significant. If they're above this area, they're statistically significant. So that's kind of the basic interpretation. As I said, the data is does not have a white noise, so its mean is not zero, standard deviation also okay. That's data is not normally distributed is what I see over here. And so let me go ahead and share a little more on what are the types of decomposition or that you can do apart from this HP and STL. There are other decompositions like you can have or you can take the trend, the seasonality, the cycle, and do a additive. Okay, you can create an additive effect. You just do you add them up and see the effect on your dependent variable. So that's called an additive effect. And you can also do a multiplicative as well, where you take the cycles, noise, seasonality, and trend, and you multiply them. Often what we have seen is that multiplicative are nonlinear. Okay, and it helps to think that these components are combination, or the seasonality are the combination of either additive or multiplicative effect. Okay, so moving on, as our data, we can also use the we can go ahead and do a basic prediction over here. How to do a basic prediction? We can do a basic prediction using the gas power that we have. Again, it's both gas and power, so I cannot say it's a univariate. Here you can see I have done a basic prediction. I got a RMSE of 1.29. So this is how you go ahead and take the series, drop zero values, do a root mean squared, and the root mean squared is pretty good. Okay, now what I also go ahead and see over here is I have used mean absolute error. I found a mean absolute error, and I'm going to so this is the predicted versus actuals. The gas power predicted is pretty much, it follows the same effect as the actuals. I am going to show you a mean. So what I'm taking a mean of gas usage of 52 houses. So this is how it's also the same, right? Because this is what I have done over here. It's exactly the same, but I wanted to show you the actuals separately over here. Okay, now what else? Yeah, so I have 2 more minutes, so let me just quickly go ahead and let you know how to do a small investigation. You can take the chunk of the data and you can go ahead and plot them. So here you can see I've created a variable investigation, taken chunks from 8th of July to 22nd July, and I am going ahead and doing an investigation. I'm plotting them. We can figure out visually what exactly is happening. So you can do that investigation. Now comes that exporting US calendar. If I go ahead and export US calendar, I can go ahead and create 2 more variables, figure out that if the day that we have, what type of day it is. So I have created, what type of day is the sense, is it the Saturday, Sunday, Monday? In that way I have created the data. So as you can see, 28 probably was data which is 0, probably 2017-20. You have to see what date it was, but the main purpose is to show you that you can do create additional features like is holiday, was it a holiday or was it not, or US holiday, not general holiday, and then definitely it's not a Sunday, right? So it says is holiday false, so it was not a holiday, and probably this is we can go ahead and create a holiday data or a holiday feature rather. Okay, now I quickly go ahead and convert everything into categorical variable. I'm rushing because I have very less time. I ran a LSTM model. I got a prediction as well. So thank you for watching, guys.